In the last lesson, we looked at an important number set, the integers. But let's make them a little more useful by learning how to do some things with them, namely the operations, adding, subtracting, multiplying, and dividing. So firstly, the sum of any set of numbers is the result of their addition. A couple of other terms that may be new to us are additive identity and additive inverse. The additive identity is the number 0 because its sum with any other number is just the other number. A positive number and its negative are each the additive inverse of the other because those numbers sum to 0. For our examples, we're going to model the operations. That is, use, in this case, number lines and tiles to represent what the operations are actually doing so we can understand their meaning. So if we have -4 plus 9, we can show that on the number line by showing -4 as being 4 units to the left of 0, and then adding 9, which means moving 9 units to the right. Where we end up is 5. We can show 8 plus -11 using tiles. So we have 8 positive tiles and 11 negative tiles. Now 8 and -8 together make 0. So if we take those away, all that we're left with is -3. Now the difference of two numbers is the result of their subtraction, which is the inverse of addition. This means we can subtract a number by adding its opposite. If we want to show 5 subtract 7 using tiles, we can start by having 5 tiles and then take 7 tiles away. Well, this is a bit of a problem because we don't have enough tiles to take away. Well, what we can do is we can add this, 2 positive tiles and 2 negative tiles. We know together that their worth is 0, but that gives us 7 tiles, 7 positive tiles we can take away. If we do that, we're left with -2. We can show -3 subtract -12 on the number line. First, we can move 3 units to the left from 0 for -3. Now, if we were adding -12, that would be a further movement to the left. However, we're subtracting -12, which means we need to do the opposite, which is actually 12 units to the right. Notice that subtracting -12 is actually the same as adding 12. What we get is the result of 9. In fact, in general, any time we're subtracting a negative number, we can always write it as adding a positive number. So 6 subtract -9 is the same as 6 plus 9, which is 15. -8 subtract -4 is the same as -8 plus 4. And -5 subtract -11 is the same as -5 plus 11. Now, the product of a set of numbers is the result of their multiplication, which, if you didn't realise it, is actually just repeated addition. So if we have 2 factors, that is, 2 numbers we're multiplying, one factor counts how many times the other factor is being added. So if we have -2 times 7, that's the same as saying we're going to add -2 to itself 7 times. If we show this on the number line, and we have -2 and -2 and all the way till we have 7 of them, we get -14. If we want to show -3 times -4, we need to add -3 repeatedly. This would be easy enough to do if we were multiplying by +4. We would just have that 4 times. But we're multiplying by -4, which means we actually need to go in the opposite direction of -3. If we do that 4 times, we actually get the result +12. Now, the quotient of two numbers is a result of their division, and division is the inverse of multiplication. Every division asks us what we should multiply the divisor, that's the second number, by to get the dividend, which is the first number. So if we have -15 divided by -3, it's asking the question, how many times do we multiply -3 in order to get 15? If we show that here, and we have -3 once, twice, 3 times, 4 times, 5 times, we get -15. So our result is 5. If we have 12 divided by -6, we want to show how many times we need to have -6 in order to get 12. Well, there's a problem here. If we just keep doing -6 and then -6 and then -6, that's a movement to the left. However, 12 is a movement to the right. So we're not going to be able to multiply by a positive number. We need to multiply by a negative. If we find we do that twice, we get to the 12 that we want, and our result is -2. Notice that whenever we multiply or divide by a negative, we reverse the sign or direction of the result. Therefore, the product or quotient of two negative numbers is positive. So for some examples, if we have two positive numbers, multiplying or dividing, we get the result as expected. If we have a negative number, either multiplied or divided by a positive number, that positive number doesn't change the direction of our sign. So our result is negative. If we have a positive, which is then multiplied or divided by a negative number, that negative reverses the sign of our original number. So we get a negative result. And if we have a negative number, which is multiplied or divided by another negative number, that second negative reverses the sign. And so the result we get is positive.